The benefit of application problems is that it usually allows us to draw a picture. So this suspension bridge might look something like this. We have a parabola, touches the bridge, and then veers off in both directions. Let's draw that a little more symmetrically. Maybe a point right here, and goes up like that. Alright, now that we have this parabola drawn, we know some details about the dimensions. We know that the towers at the left and right that I've drawn here are 400 feet apart, so I know this distance is 400 and this distance is 100. If the cables are at a height of 20 feet midway between the towers, so in other words, instead of the line being down here, it's all the way down here, and there's a distance of 20 feet right here. If the cables are at a height of 20 feet midway between the towers, what is the height of the cable at a point 40 feet from the center of the bridge? So in other words, what we're wondering is what is the height here? Alright, now to figure out this y value there, it might be helpful to try and find out the equation, or an equation at least, for our parabola. And I think it'd be easiest to put the origin right at the center of the bridge, right? The midway of the bridge, midway point of the bridge. That way we can say the height is just the height from the bridge, and the x value is just the distance from the center. Alright, knowing that, we need to know a few things. Where is the center? What are A and B? Because remember, or excuse me, what is P? Because if you remember, the formula for a parabola looks something like x minus h squared equals 4py. And if y is our height, x is our distance from the origin, x is the distance from the midway point on the bridge, then this function represents the parabola. Now the center, I need, instead of just y, I need y minus k there. There we go. If you notice, the center is just 20 feet right above the origin, and that means that the h and k are 0, 20. So we can set this to be x minus 0 is just x, so we have x squared equals 4p times y minus 20. Alright, the only variable we have left is this p, but we don't know where the focus or directrix is of this parabola. So our other option is to find a point on the parabola that we do know. And we actually know 2 points. We know this one and this one. And by know a point, I mean the coordinates, because we know that the distance from the origin is 200, half of that 400 there. And then the height from the bridge is just 100. So 200, 400 is the point we're going to use here. Excuse me, 100. There we go. So we have the equation 200 squared equals 4p times 100 minus 80. Or excuse me, minus 20, which is 80, of course. 200 squared is 40,000. And as I said before, 100 minus 20 is 80. Now we can actually multiply the 4 and the 80, of course, to make 320p, also switching the sides real quick, equals 40,000. The last part we need to find the equation is just a short division of 40,000 divided by 320, which gives me 125. Now that we know what p is 125, we can write the entire equation. That is, x squared equals 4 times 125 times y minus 20. And we can even evaluate 4 times 125, which would be 500. This is equal to 500 times y minus 20. Alright, now back to what the question was asking, which is, what is the height of the cable at a point 40 feet from the center of the bridge? Well, remember that x is distance from the center of the bridge, so x equals 40 is a very fair assumption, and y is the height of the cable from the bridge. So all we have to do is plug in x equals 40 and then find y. So we have 40 squared equals 500 times y minus 20. 40 squared being 1,600, which we can then divide by 500 to get 1,600 divided by 500 is equal to y minus 20. And we can find a decimal approximation of this, which would be 3.2. Y minus 20 is equal to 3.2. So 1,600 divided by 500 is 3.2. So we have y minus 20 is equal to 3.2. So y is then just equal to 23.2 when we add over the 20. The original measurement is in feet, so we can measure this y in feet.